So as you see here, we have 6 juniors and 6 seniors, and we're trying to form 3 disjoint teams. So 3 teams with 2 juniors and 2 seniors. So this is what we're trying to solve for. We're just going to box it. And when you have nowhere to start on a counting problem, you always want to start somewhere, obviously. So we'll start with the first team. All right, team 1. Oops. Let me box that again. Okay, team 1. So team 1, we're trying to pick out of the six juniors. We'll start with the juniors first of all, and we're trying to pick 2 of them. So 6 choose 2. 6 juniors to choose from, and we're choosing 2 of them. For those of you who don't know what this symbol is, it's the choosing symbol, and I'll give you a short example right here. But if you want me to cover it in a long form video, then I'll also cover it. So leave your thoughts in the comments down below. Okay, wait. Anyways, so we have 5 choose 2 right here, and basically what this is saying, there's 5 options to choose from, and we're choosing 2 of them. We're choosing 2 of those options. So we can write it out. 5 choose 2. We can write it out as 5 times 4 divided by 2 times 1. And as you see here, there's the first option. The first thing we do is choose 5. So there's 5 choices for the first option, and there's 4 choices for the second option. However, we do have to divide by 2 because, again, the order doesn't matter here. So any way we choose it, it really doesn't matter. There's 2 ways to choose it. We can first choose the first guy and then the second guy, or the second guy and the first guy. It really doesn't matter, so we divide by 2. We're overcounting it by 1 extra copy, so we're dividing it by 2. That's the simple explanation, but there's a lot more to it, so if you want me to cover that, obviously just leave your thoughts in the comments down below. Okay, now we can move on to team 2, and again, we're only covering the juniors. Don't worry, we'll cover the seniors eventually. And as you see here, we have team 2. So now, since we already picked 2 juniors, we have 4 juniors left. So out of the 4 juniors, we're trying to pick 2 again, because we only need to pick 2. The problem states that each team should have 2 juniors and 2 seniors. But obviously, we're only worrying about juniors for right now. Okay. So now we can move on to the third team. And again, once again, we already picked another 2. So in total, we already picked 4. And now we only have 2 options left. So 2 juniors are left, and we need to pick 2 of them. Okay. And we have to multiply all these choices for the total number of outcomes. And so, yeah, we can calculate this. So this is 6 times 5 divided by 2 times 1, which is 15. We have 4 times 3 divided by 2 times 1, which is 6. We have 2 times 1 divided by 2 times 1 is equal to 1. And another example, as you see here, we have another reason why this works is we can think about it very logically. If we have 2 juniors and we're picking 2 of the 2 juniors, there's only one option to do so. And it's just picking them. Okay? So that's why there's only one option to do so. Okay, so we multiply all of them and we get 90. And we don't even need to do the second case for seniors because once again, it's the same. It's the same. We're checking 2 seniors to start with out of 6. And then we are picking 2 seniors again out of 4 and 2 seniors again out of 2. So we can multiply 90 by 90 to get our final answer. However, wait right there. We have to correct for overcounting, because once again, it doesn't matter which order we choose the teams. We corrected our overcounting for choosing the people, and now we have to correct our overcounting for choosing the teams. Each choosing, in this case, we chose the players on team 1 first, we chose the players on team 2 second, and we chose the players on team 3 third. We had to correct for overcounting by dividing by 6, or 3 times 2 times 1, because that's the number of ways we overcounted by. Because as you see here, we can arrange team 1, team 2, and team 3 6 different ways by the choices by the order of picking first, second, and third. So we have to correct for our overcounting, and we get this. So we have 30 times 45, and we get 1350 for our final answer. And let's see if there's an answer choice. There is answer choice B.